So Savannah, we're going to skip the video. We already watched it. The Atwood machine is a pulley system. And again, the key idea is two ideas. Rowan, idea number one, if M2 moves up, M1 moves. And they'll move at the same acceleration because they're attached to the same rope. We said the other day, we're not allowed to jerk on the rope and make the rope go slack or anything like that. So the acceleration will be the same. Here's our first thought problem right here. Example 1 says this. Suppose we had our perfect Atwood machine. So remember, Logan, our perfect Atwood machine, this pulley here has no friction, and these ropes have no mass because we want to keep the math easy. Suppose we have our Atwood machine, and we put equal masses on either side of the Atwood machine. Like this, if you look up, Logan, my friend. So here's an Atwood machine. These two masses are equal. Now there is friction in this pulley, so we have to imagine there's no friction. And then suppose we lift one of the masses higher, this one, like this. When I let go of this higher mass, what happens? A, nothing. B, the higher mass falls down because, gravity. Or C, the higher mass goes higher because this one's closer to the earth and feels more gravity. Okay? That's the question. Oh, you can't call out an answer. We're going to vote. And once again, how high you hold your hand up is how sure you are of the answer. So you follow the thought question? Who says A, Mr. Dueck? Nothing happens. The system remains at rest. A. 1. Who says B, the higher mass is going to fall? Because, gravity. 0. Who says higher mass is going to go higher? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What did you vote? Okay, 17. I'm not going to answer the question. Well, you know what? This is a job for us. I think we can answer this ourselves. So I'm going to look at this situation here. I'm going to zoom in like that. And I'm going to label the forces on this left-hand mass. What are the forces acting on this left-hand mass? Get the obvious one. So I have this mg. What else? Is there a rope? So what have we called that force from a rope? Is this sitting on a surface? No normal force. Those are the only two forces acting on that bad boy. What are the forces acting on this mass? Get the obvious one. Now, normally I call this first mass M1 and the second mass M2, but doesn't the question say the masses are identical? Okay, so I'm just going to use M for both of them. And tension, yes? Most of you picked C. So those of you that picked, and since that's most of you, since those of you that picked C, who's winning? This one here? So what you've just decided, if C is correct, that anything that ends up pointing down on the right-hand side will be a winner plus. Anything that ends up pointing up on the right-hand side will be a loser minus. You got the argument, Riley? Let's write our equation. So, and again, we're going to walk along the rope the same way as last day we walked along the rope. This rope has a complete 180-degree bend because of the pulley. We did a couple last day that had a 90-degree bend because of a pulley. Okay. Who's winning? mg. And then this tension here, winner or loser? Minus. Now, this tension here, Rowan, you might be tempted to call it a loser because it's pointing up. But if you follow it, follow it, follow it, follow it, and follow it to this side, I think when it gets to this side, which way is it going to be pointing? Winner plus. And you might be tempted to say that this mg, Logan, is pointing down and it's a winner plus. But Logan, if you follow it, follow it, follow it, follow it, follow it, when it gets to this side, you got to use your imagination. But you see, I think it's going to be pointing up. Loser minus. What's that always equal? Do I have forces from more than one mass? Then it's going to be M all times A. Wait a minute. Now I'm not relaxed. Now I'm feeling tension. Because what else cancels? Now I'm scared. Well, what's left behind on the left then as a number exactly? When everything's gone, what number do we use for that? So we have this strange thing. 0 equals... Okay. How would I get the A by itself? So the acceleration is going to be 0 divided by... What's 0 divided by anything? So what's the acceleration, Courtney? So if we're not accelerating, what must be the correct answer? A or B or C? Yeah, you sit up proud. That's a nice physics proof. Do you notice no numbers? We started using our physics skill and we arrived at the correct conclusion. You're correct. It's got to be A. And when it says using principles of physics, explain your answer, I'm drawing an arrow pointing to that and I'm dropping the mic and walking off. That's really handy, by the way. How many of you have been on an elevator before? Okay. In real life, what you don't see in the elevator shaft, there's always a counterweight that's the same mass as the empty elevator car. And that way, when the elevator stops on the 9th floor and everyone gets off, the motor can shut off and the car will just stay there. We're not having to burn more energy to keep it there. It's very much more efficient. It also means that the motor only has to lift the mass of the people in the elevator. It doesn't have to lift the mass of the elevator car because of that counterweight. So one place we use Atwood machines are in actual elevators all the time. We use a counterweight all the time. Cranes as well. We'll use a counterweight all the time. It's way smarter. So let's do one with numbers. I'd like example 2. There's going to be an Atwood machine on your test. I'm just going to tell you right now. I guarantee it. And what I'll do is I'll give you both masses and I'll ask you to find the acceleration and I'll ask you to find the tension. Okay. In the diagram below, M1 is 6.2 kilograms. M2 is 2.8 kilograms. If you want to write those in, you can. You don't have to. I can remember that they're there. Savannah, what does A want me to do? That's my winner minus loser shtick. But you know what I'm going to do first? You know what this is a good job for? And I'm going to start on the left with M2. What are the forces acting on M2? Get the obvious one. I'm going to go M2G. And is there a rope? Tension. Normal force? Does it look like it's sitting on a surface according to the picture? No. If they put a table in or something like that, then I'd bring in a normal force, but don't get normal force loopy. If it's dangling in midair, ain't happening. Savannah, what are the forces acting on M1? Get the obvious one. So M1G. And tension. Who's winning? Savannah, which mass is heavier? Look at the numbers that the question gave you. I've scrolled down. How big is M2? Okay, so ready? Let's try that again. No one noticed. Let's try that again. Savannah, joy of my heart, oh clever girl. Which mass is heavier? Oh, you are so clever. I knew you'd spot that right away. And so which mass is going to move down? M1. Which mass is going to get lifted up? M2. So here's my question. Which force is winning? That's the question. For anybody out there, which force is winning? M1G. I find these a little bit easier to do than the ones we did last day because I can imagine one going up and one going down. My brain can just imagine that a little easier for some reason. So, ready, Savannah? Part A says write force equations. Who's winning? And what you have just decided now is anything that ends up pointing down, once it gets to the right-hand side, is going to be winner plus. Anything that ends up pointing up on the right-hand side is going to be loser minus. And once again, I'm just doing an equation for the forces along the rope. So, M1G, now what? Not yet. Winner or loser, minus or plus? Good. And then when you follow around the rope, when you get to this tension, you might be tempted to also say winner plus because it's pointing up. But Savannah, can you see when you follow it on this side, which way will it end up pointing? Loser minus, or winner plus, not loser minus. And this M2G, you might be tempted to say winner plus because it's pointing down. But Riley, can you see when you follow it, when it gets to this side, which way will it end up pointing, Riley, my friend? Yep. And that's going to be, do I have forces from more than one mass? M all times A. Oh, Savannah, join me, please. Oh, good stretch, yeah. Ah, these are such relaxing questions. Yes? M2, Mr. Dueck. Is that what you're going to point out? Thank you, candy for you. And Kenzie, you get a candy for sticking to your guns on the thought problem and thinking it through. So, Savannah, we get to do that. How would I get the A by itself? Divide by what? Yeah, M all, which is going to be M1 plus M2. So I'm going to put A equals, you said I'm going to divide by M1 plus M2, and it looks like M1G is going to drop down and a minus and an M2G. And again, you can try and memorize all these equations. Rowan, put the cube away and write this down. You can try and memorize all these equations. Sam, don't bother. The 1 second it takes to derive them is a much better way to get to. So, Savannah, what was M1? Thank you. G, I know, is 9.8. You've all probably memorized that, even though you didn't try to. What was M2? I've scrolled down. 2.8. G is 9.8. And on the bottom, it's going to be 6.2 plus 2.8. Again, here, I'd like to strongly encourage you, try typing this into your calculator. I think you're going to need brackets around the top, and you're going to need brackets around the bottom, because it's a fraction with more than one thing on the top and more than one thing on the bottom. Blake, you've typed it in already, right? You have? Okay. What'd you get? Oh, built-in error check. If I cut this rope, what's the maximum the acceleration can possibly be? I know this answer is going to be less than 9.8. And I can use that anytime I have a hanging mass in a question and I'm finding an acceleration. I can take that to the bank, and that's nice to have. So now you're typing it in, right, Blake? Good. 6.2 times 9.8, take away 2.8 times 9.8, close off the top, divided by, open a bracket, 6.2 plus 2.8, close off the bottom. Do you get 3.70 and then 2 repeating? I'll go 3.70. Units, Savannah, it's an acceleration. Thank you. By the way, A only wanted us to write the equation, so if you all look up, put a little part B right there, because now we found the acceleration. I got carried away. Kenley, what's part C want me to do? One mass. I'm going to write an equation for an individual force using an individual mass. What do you want to find it with, mass 1 or mass 2? Okay. I'm going to tell you that I probably would have chosen mass 2, and I'll show you why, but it's really not that big a deal. So mass 1, you said, look at mass 1. Which way is mass 1 accelerating? We have to remember, because we've been doing this now. So who's winning? Which one? I got several MGs out there. Be very fussy and specific. What? Who's losing? And I'm going to stop there. I'm only writing it for mass 1, so what's it going to equal? Which M? M1A, right? What's right in front of the T? What's right in front of the T? Swappy dance. Now, pause. If you had chosen mass 2, which way is mass 2 accelerating? Who's winning? Who's losing? What's that going to equal? M2A. It's slightly easier to get the tension by itself because you're plussing. But no matter what, we're doing both of these in our head. to get to the next line. And that's why I said to you, it really doesn't matter which one you pick. So you went with mass 1. I can do the swappy dance in my head. Some of you, if you want to use this one plus the M2G over, so you'll get either tension equals M2G plus M2A, or you're going to get M1G minus M1A equals tension. You know what? Let's have some fun. How about this half of the class? You folks do this equation using M2 and using your answer button for A. This half of the class will use Kenley's equation using M1 and your answer button from A, and I guarantee we'll get the same answer to an infinite number of sig figs. Kenley, I'm going to do your method. What was M1? I've scrolled down. Was it 2.8? So, M1? Oh, M1 was 6.2? You're right, sorry. So 6.2 times 9.8 minus 6.2 times answer button. And I got 37.8062 repeating. Did you folks get exactly the same thing using your answer button? So it really doesn't matter which one you pick. Sometimes there'll be one that's way easier. Pick that one, but you'll get the right answer as long as you're careful no matter what. And tension is a force, so newtons, right? That's the Atwood machine. You have to decide which one we're using. Okay? So some people would have been using the 6.2 mass and having a slightly different equation from the 2.8 mass. Let's go to example 3. I like example 3. I like example. There's going to be an Atwood machine on your test. So here's what I'm going to do. I'm going to freeze the screen. You can try this on your own. Let's set up the free body diagram, though, first. So on the left, on the 3.5 kilogram mass, what are the forces acting on it? Get the obvious one. I'm going to call that M1G because usually I start with M1 on the left. What else? Yep. What about on the right? I'll call it M2G and tension. Rowan, how big is the mass on the left? On the left, the other left. If you hold your hand up, the one that makes the letter L, when the palm, okay. Sorry? How big is the mass on the right? Which force is winning? M1G or M2G? Yeah, because it's bigger, okay? I could put the heavier mass on this side on your test, so just don't always think, oh, it's always this way. Look at the masses, please. Now, I'm going to freeze the screen. See if you can come up with the winner minus loser equation on your own. See if you can find A on your own. See if you can find tension. Doesn't matter which mass you pick, although one will be slightly easier on your own. I'll unfreeze the screen every so often, but try doing this one on your own. Good stretch. If you're stuck along the way, that's what I got for the acceleration. I even pasted my calculator in there so you can see what I got to all the sig. Am I wrong? A couple more minutes. I've done a bunch of these. I did make a mistake. Well, that was silly. Dueck. Dude. Can't believe I did that. It's plus 3 point. I dropped the wrong thing. Instead of the 5.7, I dropped it. Well, okay, I can fix that, thankfully. Clear. Backspace. 5.7, Mr. Dueck. Jeez. Do you get 2.343478 that there? I wish I'd made that mistake on purpose, but I hadn't. I just went too fast. As Courtney pointed out, I went fast. You're right, I should have been more meticulous. All right, I'm going to freeze the screen again. I'm going to find tension. I already feel some tension because I made a mistake. Okay. I got that right? I used mass 1. If you used mass 2, your equation would end up being tension equals M2G minus M2A. But if you use your answer button, you'll still get 42.50217391, I think. Yeah.
How do you know
Which mass is heavier? So which way is mass, the heavier one, accelerating? So which mass is winning? The heavier one. So which force is winning? The M2G. That's how I know. Physics 12 will get more difficult with like 3 and 4 masses and extra pulleys and stuff, but figure out which mass is the heavier one. That's what's doing the lifting, doing the accelerating, doing the winning force. Good question. Is that all right? How many got both of those? Sorry, I can't raise my hand. How many of you got both of those? I have to keep my hand down because I got the acceleration wrong. Jeez. Put your pencil down, look up. I like example 5. I like example 5. I like example 5. Example 5 is a nice question. Example 5 is a tough question. Why? What's example 5 asking us to find? Logan, what's example 5? What's example 5? What's example 5 asking us to find? Find what? So in the previous question, Logan, I gave you both masses and I said find the acceleration and find the tension. Here I'm reversing that. I'm giving you one mass and I'll either give you the tension or the acceleration and we can find the other mass. Follow it? You know what this is still a good job for? Yeah. What are the forces acting on M1? Get the obvious one. So I'm going to have M1G tension. And I'm going to have M2G tension. Now, Antonio asked me earlier, how do you know which one's winning? I said the heavier mass. Here, because I don't know one of the masses, I have to tell you which way things are accelerating. If I don't, this question is unsolvable. So, Logan, can you read to me everything after the word and, where it says M1?
M1 is accelerating upward.
Which way?
Upward.
Which way? So I'm going to make a little note here. A is that way. A is that way. That's just so I don't accidentally forget. Writing that takes all of 1 second, but, you know, avoid making mistakes, right? So which mass do you think is the heaviest one? Okay, we'll come back to that. Normally, I would say, who's winning? And Kelsey would say, Kenzie, wow. Kenzie would say, I'm slumping right now. And I normally don't write this down. I would go, okay, M2G minus tension plus tension minus M1G equals M all A. There's a bit of a problem here. I don't know A or M2. Two unknowns. So we're going to, again, do this completely backwards. When we did this, when we knew both masses, we wrote an equation for everything. Then we looked at one mass. Here, since we're missing a mass, we're going to look at the mass that we know. We're going to look at the mass that we know. Sam, which mass do I know? Let's write an equation for M1. Which way is M1 accelerating, up or down? Who's winning? Only look at mass 1. We're only writing an equation for mass 1. In your mind, Sam, do that. Don't do that in real life, but in your mind, do that. Who's winning? Pardon me? Yeah. Who's losing? Which one? I've got several of them out there. Stop saying gravity. I need you to read me what it says on the free body diagram. What? And that's going to equal M1A. Now, why is that nice? I can find A. How would I get the A by itself? So A is going to be tension minus M1G all over M1. How big is tension in this question, Sam? I have to tell you that, otherwise this is not solvable. Minus, how big is M1? 3.2. How big is G? 9.8 divided by 3.2. Get your calculators out, folks. What's the acceleration here? $7.85625. And I'm going to keep everything. I'm going to use my answer button, but I'll even write this whole thing down because I'm going to use this. And it's not what they asked me to find. They want me to find the mystery mass. 7.85625. Sam, you okay with that? It's not what they wanted me to find. What do they want me to find? Sam, what do they want me to find? I'm going to do the same thing I just did, but I'm going to do it for mass 2. I'm going to write an equation for mass 2. Which way is mass 2 accelerating, Sam, my friend? Who's winning in mass 2? Can you, again, please read me the force from the free body diagram? Stop saying gravity, because gravity appears all over the... That's what we want. Which force is losing on that part of the diagram? And I'm just writing an equation for mass 2, so equals M2A. Sam, what am I trying to find? How many M2s do I have in this question? How many would I prefer? 1. You know what? Let's get the M2s to the same side. I'm going to do the swappy dance here. I'm going to move the tension there, and I'm going to minus the M2A there. That's going to give me M2G minus M2A equals tension. You okay with that, Blake? Nothing important on your phone? No? Good. Sam, how many M2s do I have? How many would I prefer? You know what would be really cool? It would be really cool if there was a Math 9 operation that I could pull out of my back pocket that would turn this from 2 M2s into 1 M2. And there is a Math 9 operation. No, not by squaring it. I want a single M2. Is there an M2 in this term? Is there an M2 in this term? If I gave you something that looked like this, don't write this down, look up. If I gave you something that looked like 5xy minus 3x equals 12. I'm thinking of the math F word, not the F word that you're thinking of. What? What kind of factoring? You used 3 letters to describe this, I think. 3 words, but you abbreviated it as something, something, something. Something, something F. Greatest common factor, GCF? Yes? Because there's an X in everything. Sam, is there an M2 in everything? We can factor it. What will be left behind in the brackets? I think a G, a minus, and an A. Yes? Multiply it out in your head to double check, because that's what you usually did to check in Math 9, equals tension. Sam, how many M2s do I have? Now. Huh?
1.
How many would I prefer? Woohoo! Who knew that Math 9 was useful? But it is. How would I get the M2 by itself? How would I move that bracket over? What's the bracket doing to the M2? So how will I move that bracket over? Are you saying, Mr. Dueck, you had this in mind when you started doing all that formula manipulation stuff? Yes. So listening to you, Sam, you're telling me that. Don't try and memorize this equation. It might not be that equation next time. It all depends on which way stuff is accelerating and what your forces are. I've scrolled down, Sam. What was tension? They told me that. I think did 56.5. And then G was 9.8 minus. And A was, I'm going to write 7.86, but I'm going to use my answer button there. It was 7.85625, and I don't want to round off if I can avoid it. Is this a fraction, Sam? More than one thing on the top? Oh, so I don't need brackets around the top. Definitely need brackets around the bottom. I'm going to make one more prediction, though, also. If mass 2 was in free fall, Jackson, what would its acceleration be? 9.8. We're ditching the negative in this unit. What was the actual acceleration? 7 point something? You know what? That's almost as big as free fall. I'll bet you mass 2 is huge compared to mass 1. How big was mass 1? I'm guessing mass 2 is in the 20s or in the 30s. Oh, yeah. 29.1. I kind of, once I saw that acceleration, I already had a bit of a gut instinct that, hey, I'm not going to get 5.6 as an answer. I'm not going to get 592 as an answer, but I figured I'd have something in the 20s, 30s, or 40s. 29.1 kilograms. On Monday, we're going to finish off example 6, finding a missing mass. I'm going to give you some of the homework right now. On Monday, I'm going to give you the rest of the homework. I'm going to give you a take-home quiz. We're done on Monday. On Wednesday, we're going to mark the take-home quiz. I'm going to give you a big review. I'll probably give you the review assignment on Monday because some of you have told me you want to get a head start on it, but that's what we'll work on Wednesday. So we're in pretty good shape right now to have your test be a week from Monday. Then what are we going to do, Mr. Dueck? I'll tell you in just a second. But for now, if you want to get a head start, we can do number 1. You can do number 2. I would probably do a quick sketch and a free body diagram on a separate piece of paper next to each of these questions. You can do number 3. Number 4, they're asking us to find a mass. I will assign that eventually, but for now, because I've only done one example of finding a mass, I'm going to say part 1 of your homework is number 1, 2, and 3, and you also have some other missing homework that you need to work on. Put your pencils down, look up.